There is a retired electrical engineer in rural Tennessee who has not purchased a new appliance in 31 years. His dryer is a 1993 Whirlpool. His washing machine is a 2001 Speed Queen. His refrigerator has been cooling the same kitchen since 1997. Every one of them still runs, and not because he has been fortunate. He has been watching, and what he has been watching is a pattern so deliberate, so precisely engineered, and so staggeringly profitable that the companies behind it have spent years conditioning you to read it as ordinary bad luck. Your appliances are not dying from age, they are dying from a single component. In most cases, a component that costs between $4 and $15 at wholesale, seated on the main control board in a position that guarantees failure within a predictable window. Appliance manufacturers run accelerated life testing on every component before a product ever reaches a showroom. They know exactly when that component will fail. They chose it anyway. In the early 1990s, the average large household appliance routinely lasted well over 15 years, in many categories, closer to 20. Washers, dryers, refrigerators, they were mechanical systems. Timers were physical dials. Thermostats were bimetallic strips. A technician with a basic understanding of electricity could diagnose a failure, order a part, and fix the machine in an afternoon. That repairability was the problem. A machine that could be fixed indefinitely was a machine that never generated a replacement sale. The solution arrived dressed as progress. Starting in the late 1990s, manufacturers replaced mechanical controls with digital electronic control boards, touch displays, programmable cycles, precise temperature management. It all looked like a genuine upgrade. Underneath it was a structural trap. Every appliance now had a single point of catastrophic failure sitting inside a hot, vibrating, humid environment, populated with components chosen not for longevity, but for price per unit at scale. The component that kills more appliances than any other single part is the electrolytic capacitor. A capacitor stores and releases electrical charge to regulate power flow across the board. Industrial-grade versions, the kind used in military electronics, are rated for tens of thousands of hours of continuous operation. The capacitors installed on residential appliance control boards are rated for a fraction of that. Under the heat of normal operation, the electrolyte inside them slowly evaporates through the rubber seal at the base. When enough is gone, the capacitor fails, the board loses voltage regulation, and the appliance stops. You call a technician. He quotes you a replacement control board at $250 to $400 plus labor. You do the arithmetic against the cost of a new machine, and you end up back at the store, right where the manufacturer's product lifecycle team planned for you to be. Independent repair technicians, the ones not affiliated with manufacturer service networks, the ones whose livelihood depends on actually fixing machines rather than selling new ones, have documented this pattern across thousands of service calls. The story is almost always identical. A capacitor on the failed board, visibly bulged or leaking, that retails for under $3, and a manufacturer quote for an entirely new board that makes replacement feel rational. Most homeowners never question it. They do not know the board itself is fine. They do not know the $2 component is the only thing that failed. They hear the number, picture the pile of money, and choose the new machine, which is the only choice the system was designed to leave them. This is the first unlock. Electrolytic capacitors are labeled with two numbers on their side, capacitance in microfarads and voltage rating. These are universal specifications, an identical replacement or a higher rated part that will outlast the original by years. You'll costs between $1 and $4 from any electronic supplier. A failed capacitor does not fail invisibly. The top of the cylinder domes outward rather than sitting flat, and in worse cases, you will see dried residue around the base. You can identify the failure with your eyes before you touch a single wire. The repair requires a $15 soldering iron, 40 minutes, and one afternoon watching a how-to video. This applies to Whirlpool dishwashers, GE refrigerators, LG washing machines, and the vast majority of major brand appliances produced after 2000. This is why the engineer in Tennessee has not bought a new appliance in 3 decades. The machines do not wear out. The cheap components on their boards do, and cheap components can be replaced. The second unlock is about heat. Every refrigerator extracts heat from the interior and dumps it through condenser coils, either on the back of the unit or behind a front grille. Those coils accumulate dust over time, and as the layer thickens, the coils cannot release heat efficiently. The compressor compensates by running longer and harder. A compressor running consistently above its design load reaches mechanical failure well ahead of its intended service life. The replacement cost runs between $400 and $900. The prevention is a coil cleaning brush, under $20 at any hardware store, used for 20 minutes twice a year. Appliance repair professionals report that dirty condenser coils are one of the leading causes of premature compressor failure. The manufacturers know this. The mention in the user manual is brief, in small print, in a section most people never reach. The third unlock is water, and it applies to 3 machines simultaneously. Sediment accumulates at the bottom of water heater tanks over years of operation, sitting between the heating element and the water like a layer of insulation and forcing the element to run at temperatures well above its design specification. An element forced to run longer and harder than it was built for will fail years ahead of schedule, a fact the manufacturer's engineering team understood before the product ever shipped. Elements pushed beyond specification fail early, and a failed water heater runs between $300 and $800 to address. An annual tank flush, a garden hose on the drain valve, run until the water clears, removes the sediment entirely, and can meaningfully extend the unit's service life, in some cases by several years. Washing machines and dishwashers accumulate mineral deposits in a different form, restricting spray arms and inlet valves and forcing motors to work against resistance they were never designed for. A monthly cleaning cycle with a cup of white vinegar costs nothing and prevents the progressive mechanical strain that shortens the life of both machines. The fourth unlock changes how you think about every future purchase. The electronic control board architecture that enables the capacitor kill switch did not exist in machines built before roughly 2004. A pre-2004 dryer runs on a mechanical timer, a centrifugal switch, and a motor. No circuit board. No single point of catastrophic electronic failure. When something goes wrong, the failed part is mechanical, visible, and still available for order. Estate sales and appliance liquidators sell these machines regularly for between $50 and $200. A 1998 Maytag dryer with a cleaned lint path and a $20 drum seal runs reliably for another 2 decades. The parts are still manufactured, the repair is still learnable, and the machine will never hand you a control board failure that cannot be economically justified. The appliance industry built its entire replacement revenue model on your not knowing any of this, on capacitors that cost less than a cup of coffee, on coils that clog quietly, on sediment that builds invisibly, and on the assumption that the person standing in front of a dead machine will reach for their credit card before they reach for information. That assumption has been correct. For most people for 25 years, the engineer in Tennessee is not exceptional. He is informed. And now, so are you. The machine in your kitchen or your laundry room that you assumed was finished may have nothing wrong with it that a $3 part and an afternoon cannot fix. Before you call the showroom, call that possibility by its name. It is the loophole, and they were counting on you never finding it. The same philosophy of engineered failure running through your appliances is also running through the water heater in your basement right now. Except there, the component designed to fail was given a name directly on the warranty card, and that name was written specifically so that when it fails, the coverage does not apply. That is a story worth knowing before your next cold morning.